morning, everyone. Today with me, my colleague NK is here. He is from the embedded system background, and he is doing his masters and has worked in the industry also. Regarding his area of expertise, which is basically lies in the STM32 microcontrollers, then Raspberry Pi, and the Atmega 32. So these are the things he has explored. Now he is working with the antennas and the wireless communication also. But then everything will be boils down to the embedded system basically, and then how the hardwares are implemented and the communication has been done. So that kind of work NK is exploring now. So let's discuss with him and then see what he can suggest and what he can guide to the students in this direction. Okay. So without any further delay, let's start. Hello, hi NK. Good morning.
Hi sir. So how are you?
I'm
Uh,
doing
s-
good. How about you?
yeah, I'm also doing good, sir. So,
Okay. Yeah.
so yeah, so
So
to yes.
to start with NK, we can start with the students who are interested to do their career in the embedded systems. Okay.
Mm-hmm.
So what you can suggest to them from where they should start?
So first of all, let's say if you're very much interested in embedded, you will have to first start learning embedded C. I think that's the most important aspect of the embedded systems. And then I would say in embedded systems. You should be very I mean you just should not stop with the you should not just stop with the basic stuff like data structures, arrays structures, and most importantly you should work on pointers. And then after doing all this basic stuff, then you should move with concepts like linked list and most importantly bit manipulation and stuff. So after getting your hands on embedded C, then you should start working with hardwares and all. So basically, you must. I mean, in from the beginning, you should start with the Arduino. Arduino would be a good choice. Uh, Starting with Arduino will be a good choice for beginners. Then you should start integrating sensors with Arduino, and then you will eventually know how sensors works, how analog and digital pins work, and then you will know what analog pins or digital pins or how they are being implemented in the software. Then moving ahead, you should actually start working with microcontrollers, which are commercial, which are actually used in industries like PIC, MSP 430, and then MSP 430 is quite updated, but still the that microcontroller, and then STM32. So the STM32 is, to my knowledge, it's a good microcontroller which is being used in most of the industries. It's basically it's an ARM based microcontroller. So I would say if you are having a good edge on ARM architecture, it would be a added advantage in learning how the microcontroller works and all. But you can eventually learn. I mean, after you can switch to STM after getting a good hands on Arduino and ESP32. So after switching to ESP32, sorry, STM32, then you should learn communication protocols like SPI, I2C, and UART and all. And you will be using these communication protocols to integrate this with, I mean, these communication protocols are being used in sensors, and you will have to use them to integrate that with microcontroller. And then, so eventually you will have face a lot of issues while initially integrating them. Then you will have to know how debugging works, what is SWD, what is JTAG and all. Then yeah, after learning all this, you'll have to build a small project, like probably a a small firmware project and all. So if let's say if you build a very small project, with probably with that you'll gain confidence. And then so these are kind of basic stuff. After that, though, you can start diving into concepts like autos and things like that. You can learn what real-time operating system is, where it can be used, and places that are actually being used. Let's say in autos plays a major role in healthcare and automotive systems. So there you can try learning what autos is, what is free autos, how that can be implemented in hardware and all. Then after learning autos and all, then you can probably start looking out for internships related to embedded systems. So probably with that, you can eventually know what is happening in industry and how things work in the industry and all. So I think by the end of this by end of an internship, you will probably have an edge over everyone, and you will probably I mean, you can probably say that I mean, you are an embedded engineer. Yeah. So that's it from me, Mr. Suraj.
Okay, okay. Thank you, NK, for the guidance. So, in terms of projects, can you discuss more about what kind of projects students should take on, and then like in their undergrad, basically?
So yeah, so projects though that depends. So if let's say if you're starting with Arduino, you can do basic sensor interfacing like DHT11. You can use ultrasonic sensor. You can just start integrating each and every sensor first. That would be ideal, and then you can start using two sensors. Let's say you can do a project in garden monitoring system where you can use couple of three sensors and then do a small project with that. Then the middle level project would be something like using a Raspberry Pi kind of stuff, I would say. Probably use Raspberry Pi and then try capturing an image or uh, try playing with that kind of data. Or talking about me, I did a project in I developed a flight computer for rocket sounding rocket. So that would be something like a middle level kind of project. So you can look what a flight computer is, and you can probably develop a flight computer that, from after interfacing these sensors, you can actually look what flight computer actually is, and probably you can start developing a flight computer. Frankly, I would say it's a uh, big thing for undergrad to work on. So it would be better if you're working with a team of 4 to 5, and that hardware would really teach you a lot about how avionics and how electronics work. Then the end level, let's say the higher level, would be working on autos, working on kernel, working on firmware projects. So that kind of exposure you will get after working with some industry. So yeah, that will be industry specific and application specific. That depends on what the application actually is. So let's say you're developing a speaker. So you'll have to deploy Linux, I mean, a driver development for integrating that speaker to your mobile phone or to your laptop. So you can check the compatibility of lot devices, and see how this external device actually works with the pairs with the system and all. So yeah, I've given three
Thank you.
projects like from basic, intermediate, and expert advanced level project. Yeah.
Exactly, exactly, NK. That's true. Thank you very much for that. So now the student in their undergrad, no, they are more interested to understand what are the online simulators are there, which can mimic the hardware basically, and without any hardware usage, they can play around the embedded systems. So, like, do you have any idea in that domain, basically?
Yeah, that is very true actually. If you're right away going down to work with hardware, that is going to be difficult. Hands down, yeah, that's true. So to let's say start with software simulators, you can use softwares like Tinkercad or Walkwe simulators and all. That would be a kickstart for anyone who's starting with embedded systems. And then there are other circuit simulators like LT Spice, Spice, and Cadence and all. From these you can learn how circuits work, how BJTs work, how amplifiers work, and how filters work and all. But after learning the electronics part of embedded system, you can dive into the sensors part of embedded system, wherein like the softwares like Tinkercad and like I've said earlier, Tinkercad and Walkwe can be used. To my knowledge, these two will be enough for anyone to kickstart their career in embedded system.
Okay, okay, that is a great NK.